Hi, this is a online recorded version of the Intro to the Foundations of Analysis in R workshop that I'll be running at the Burwood and Geelong campuses of Deakin in the week of the 10th of April 2017. This workshop is basically designed to give you an introduction to converting your workflow from an existing system like SPSS or like Stata and port it into R. And hopefully we'll give you a bit of an overview right now about why that might be useful, why you want to do that, and so on, so you can convert other people to doing the same. But also we'll get you started on doing some work in R, and then we'll let you loose on the materials from the workshop itself. We run this workshop in a particular way. It's really short, it's really hands-on. And the reason for this is basically boils down to the fact that we know you're time poor. We know it's hard to justify spending time on anything that isn't your work, whether that's your research, whether it's your teaching, whether it's assignments, etc. And we know that it's really hard to gain benefit out of just watching people do things. As much as people might be really expert at using a particular system, watching someone do it isn't really going to be particularly helpful, because the minute you go to do it, you'll find that you didn't internalize that in the way that you thought you did. So beyond that basic acquisition of skills, analysis is really practical. And so it's really important that you get in straight away at the ground floor and actually start doing things. Also, we know that learning new systems is really tedious and strenuous, and it's not particularly exciting, but hopefully by constricting this to a relatively small time frame, we can make sure that this is not overly arduous and you can feel like you're getting something out of it. It gets over that sort of breakdown of that soul-destroying feeling of circling around, feeling like you're doing the same thing over and over again. To that point, I'm going to cut as much of the preamble as I can. I'm going to limit this to a minimal pitch of why you should be learning R. We're going to get this to be hands-on as soon as possible, and totally we're going to try and aim to get this down to a grand total of 3 hours. So why should you learn R? Well, one, R is free. This is really important for a whole stack of reasons that may or may not be relevant to you right now. The major reason why I'm a big fan of using R on the basis that it's free is, while a lot of us might have access to SPSS or Stata or some other system through work, for a lot of people that isn't an option. And particularly where, for example, those of us that teach research methods, we teach people to learn in this walled garden of SPSS or Stata, we can create the situation where students will leave our teaching environment and never be able to use those skills again. So being able to offer a system that they can go and install on their computers for free and implement all of those same skills in their own time is great. Another thing is that not all institutes are going to have the same amount of access to these systems, particularly when you're dealing with more advanced functionality in SPSS, where you need to buy additional or higher, more premium versions of the system. It can really be restrictive to collaborators or colleagues working in institutes that just don't have the resources. And this kind of relates to these other points about reproducibility. So there is now a big push, thankfully, to make more of our research reproducible, so everyone can see how and why we've done particular things in our analytic pipeline. If we have done our analyses in a closed system like SPSS, even if people can see the scripts that we've used, they can't implement them if they don't have access to the system. So again, having an open and free system is great for that. And that last point about openness, you will have run an analysis in SPSS and taken it at its word that it does the analysis in a particular way. Some of you may never even question how it does it. But nonetheless, even if you wanted to double check that SPSS or Stata is doing a particular analysis in a particular way, that's difficult. Whereas R, because it's open in terms of open source, you can dig into the processes that R uses to run particular analysis or conduct particular analyses, and you can check that it does it a particular way. And to me, that's a big selling point. It means that there aren't black boxes where our analysis is hidden in. So openness is great because we get new features all the time. This is something I kind of didn't really harp on in that earlier section. Because it's open, people can build on to R in ways that it's more challenging for SPSS or Stata. And we'll have a look at packages as we go through this workshop, and you'll be able to see how you can very rapidly extend the features and capacity of R so it can do things that are amazing. And importantly, these new features that get implemented in R really quickly, because anyone can implement these new features, can develop these new features and share them. So frequently you'll find that where someone implements a new way of dealing with a particular type of data or a particular analysis, you'll find that they share a R script, and that R script will be the instructions for how to implement that analysis. And so these features that would have otherwise taken many months for SPSS to recognize that it might be important and then implement in their baseline software, in R will probably be made available to you at the same time as that first is demonstrated in the literature, or shortly after, when someone else feels that they want to replicate it and takes the time to develop those new features. And again, as I was saying, it takes away those black boxes. Openness will mean that there are you aren't hiding the mechanisms that are at work in your data analysis pipeline. So if you have installed R, and I hope you have at this point, you may have opened up this window and recoiled in horror. This is what R looks like in the wild. This is the console, and this is basically the raw face of how you might access the R language. Importantly, I want to encourage you to never look at this again. Not because I don't think this is a suitable way to deal with R, but I feel like it's probably not the best way to deal with R. The best way I can recommend that you deal with R is to instead interact with R via RStudio. Some of you may understand the concept of an integrated development environment, and so therefore if I say RStudio is an IDE for R, that will make perfect sense. But for others of you, it might be easier to say something like RStudio is like a browser for R. So it's a shell that wraps around R and makes it easier for you to interact with the R language. So if you open up RStudio, you'll see something like this instead. You may notice that this console here on the left-hand side of this display is pretty much what was in that previous slide of R in its native form. That's exactly what it is. This is exactly how you would interact with a console. But importantly, this isn't the only feature of RStudio. You can see it's got folder access, it's got a few panes that demonstrate things like workspace and history. And this will basically improve your workflow, give you ability to do things that you would have otherwise found challenging to do through the native R interface. So what I'm going to encourage you to do now is, if you look over at this top left hand corner of this window, you'll see a page with a plus on it. This page with a plus is going to create a script, and when you press that button, it will look like this. So you'll now have something that has a new window up here, and this new window is effectively where you can write all of your instructions. So if you're familiar with SPSS, you may be familiar with the idea of a syntax, which is a catalog of all of the instructions that you're fed into SPSS for it to do a particular run of analyses or a run of data preparations. The script here is exactly like that. This is where you can put all of your instructions so you can have a record of it, which is really important if you want to make your workflow and your process and your data analysis reproducible. It's very important that you keep a script. Otherwise, you could run all of your analysis line by line in your console, but that just wouldn't be easy to track. You would lose orientation to where you were up to, and in general, it's just not a great idea. It's better for a number of reasons to keep some form of script. there are alternatives to just building scripts. So you can engage with what's called Markdown or R Markdown, and that will allow you to put your text, say for example, the full body text of your paper that you might be writing, side by side with your analysis script. And that's super useful, but beyond the scope of this workshop. So what we're going to encourage you to think about now is work closer to the way that you probably work in other environments, and just think about developing your script, and we can separate that out and discuss Markdown at another opportunity. All right. So I think I've done enough preamble and talking. We're going to step through some basics of driving R. We're going to do some calculations, get R to do some maths for us. We're going to show you how to use R as calculator with memory. Then we're going to install a package, and we're going to show you the framework of how you can leave yourself hints in your code so it can make it easier for you to come back and understand what you did at a later stage. So let me just jump over to R. I'd also encourage you to, if you have RStudio installed, to open that up. So as I said previously, you will find your RStudio window looking like this. And the first thing I want to do is to create a new script. Okay. Now, to demonstrate the relationship between the script and the console, let me just write something in the console for starters. I will type in 1 plus 1, and it will spit out 2. Now, if I type in the same thing up here, 1 plus 1, and I press enter, you'll notice nothing happened. If I press on my Windows computer, Control Enter, you'll see in the console, it's run that line of code and spat out 2. So this is how the relationship between the script and the console works. What I can do is I can bank up all of my instructions in the script up the top, and then run them as needed and that output will appear in the console later on. Okay, so you can already see running very simple maths is trivial. Okay, let's make it a little bit more complex. Let's say I wanted to get all of the numbers between 1 and 10. The way I would do that is to say 1 colon 10. And if I run that, you'll see that in the console, it spat out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Let's say I wanted to add 1 to all of those. You'll now see instead of 1 to 10, it's got the numbers 1 to 10 plus 1. So 2, 3, 4, through to 11. This is basically how R works. You feed it these types of components, and you just get it to follow those instructions. Okay, let's say I want to do these sort of things, but remember the pieces that I'm dealing with, and you'll see that this will become increasingly useful. So we'll create a thing called X, and X will be our numbers 1 to 10. The convention for R is that you use something called an assignment operator. And an assignment operator is kind of like an equal sign. And in fact, R will let you use an equal sign, but I would encourage you not to. And this basically says, make this thing, X, this whatever I'm feeding into it. So in this case, I'm going to put in that assignment operator, which is the less than sign and a minus. There is a keyboard shortcut for this, which is Alt and minus, and we'll input that in one stroke. And I'm going to say make X 1 through 10. Now, if you look over on the right-hand side, you'll now see something has appeared in my environment. It says X is equal to int, which is integer, 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Now, let's create another one. Y is equal to, let's say, let's do something a little bit more complex here, and we'll create Y, but we'll make that equal to 10 iterations of the number 5. So if you have a look, what I've said is rep 5 10 times. Now this rep with these brackets is a function. What this is kind of like is like a recipe. That's probably the best way to think about it. And that recipe takes certain ingredients. In this case, I've given it an ingredient, the first ingredient, which is what number I want it to repeat. And then I've given a second ingredient, which is how many times I want it to repeat it. So if you have a look in the environment, you'll see that I have 5 10 times in Y. So now I can create new things. I can use those X and Y to do maths. So if I ask for Z, and I ask for Z to be equal to X plus Y, you'll see that Z now contains 6, 7, 8, 9, 10, which is equivalent to the first value in X plus the first value in Y, the second value in X plus the second value in Y, and so on. Okay, so that's how to do basic maths in R. You're probably thinking this is not what I thought I was signing up for, but don't worry. Once you get these basics down and you understand the conventions of the language, things speed up relatively quickly. So let's say, for argument's sake, I wanted to know the descriptive statistics for these X, Y, and Z. You might think now of X, Y, and Z as variables. So the best way I've found to get these descriptive statistics is to use a describe function that does not exist in base R. And so to get access to that, we are going to need a new package. And a package is effectively a set of tools that someone has developed and put together so I can borrow them, right? So to do that, I need to ask R to install the package. So I'll type in install, and you'll see that it's giving me a code hint, install.packages. If I press enter, it will complete that line. Now it's asking me, and you can see this code hint tells me all of the things I can feed it. I don't need to feed it all of these details. What's most important is that I feed it the detail of what package I want. And this package is called psych. So if I run that, you'll see everything goes a little bit weird for a second, and there's pause, and you'll notice that it's running something because it's giving me the option to stop it. Something is going on in R. So it's installing, it's doing some checks, and now it's installed. Just because it's installed doesn't mean I immediately have access to it. If you go to this packages window here and you have a look, you'll see I've got lots and lots and lots of packages, but not all of them are open. Right? Not all of them are active because they're not particularly useful all the time, and you don't want to bloat up R with everything being accessible all the time. You only really want to access one thing or the things that you need at any given time. So I'm going to call upon that psych package. I'm going to ask for it to be activated. And the way I do that is I look in my library of packages. So I ask library and I type in psych. Okay, now I can check. If I scroll down to where psych is, you can see it's got a check mark next to it. Psych is open. The reason I've done it using this script is it means that if at some later stage someone else wants to understand how I've gone about doing this analysis, it's important that they understand what packages I've used to get to where I'm up to. So it's important for me to leave a trace of which packages are needed. In fact, it's best practice for me to put this at the top of my script. Okay, so the first thing that happens before anyone starts is that they load the relevant packages. It's generally not recommended that you have a install packages line inside a script. It's not polite to provide a script that installs things on people's computers, but for the purposes of this, I'm going to leave this here so you remember what's going on. Okay, so the psych package is now installed. What I can do is I can now type in describe, and you'll see that describe comes from psych. And I'll ask it to describe Z. So what you can see here is that Z has 10 values in it. It has a mean of 10.5, a standard deviation of 3.03, a median of 10.5, etc., etc., etc. So hopefully now you can understand the basics of how to make R do things. It can do maths. You can get it to save results of things, whether that's a simple instruction to generate numbers or a maths instruction into a value using the assignment operator. And you can find things like the rep and describe functions that will give you tools to do advanced things. These can be native, so in base R, like the rep function, or they can be in packages, like the describe function. There's only one additional thing I want to scaffold you with before we actually set you loose on something more challenging is comments. So obviously this is all very simple. There's nothing really complex going on here, but nonetheless, it's very important for you to keep track of what you've done. One, in case you need to share your code with someone else so they can understand what you've done at certain steps and why you've done them, but also sometimes you'll come back and look at something later on and you won't have a clue why you were doing something in particular. So the way you can help yourself is to leave comments, and leaving comments is very helpful. The way you do that is you just write a hash symbol and then you type in something. So you can say this installs psych package, this loads psych. These are pretty self-explanatory. So let's go to this and say this generates numbers 1 through 10 and assigns them to X. And this is a little bit more complex, so let's place a comment here. Repeats 5, 10 times. And finally, where I got this from. Describe comes from the psych package. Great. And you can see that despite the fact that these are on the same line and potentially might cause you woes, these do not actually get run. So it will not interfere with your script at all. Once you've put in that hash symbol, this is no longer read by R as a command, this section afterwards. So this can be a really useful tool for you to keep track of what's going on. And I would encourage you to make liberal use of comments in your own work. So let's go back to our slides for a moment. So now you hopefully know how to use R as a calculator, how to use R as a calculator with memory, how to teach R new tricks with the package, using the psych package in particular, so how to install, how to load, and how to apply functions from it, and how to leave comments. Hopefully that's leaving you feel a little bit more comfortable, but let's actually move on to a little bit more preamble. All right, so as I was noting, packages are kind of like add-ons. They give you more features. They're free. They give you new analysis options. They give you new data handling options. Some of them are trivial, like they'll do things that aren't necessarily useful, they're just fun. Because the one thing you probably will not have an understanding of until you've worked in this environment for a while, R can be a lot of fun. Importantly, because R isn't strictly within a closed environment like IBM, R developers aren't just professional programmers. There are a number of professional programmers that work on the R language, but a lot of people that will build packages for R are just other people like you who are doing research or working through or doing even hobbyists. And through whatever they're doing, they'll decide, I would like something to happen that doesn't happen by default in R. So they will write instructions for R and they'll feed it into these packages and load it onto a CRAN, which is a repository for all these packages. So it's important to think that this means that the barrier between the user and the developer is really small. So it means that once you get to a certain level of confidence, you can start developing packages yourself. or at a potentially lower level than that, you can provide feedback directly to the developers if they have a web presence like through GitHub. But that's a later point, and we'll focus on at a later stage. Okay, so packages are really what makes R awesome. Particularly, it means that you don't have as much frustration dealing with more complex things. So in SPSS, you will do your basic data handling and basic analysis, your t-tests, your RANovers, your regressions. You'll do that all in SPSS. But the minute you need to do something like path modeling, you need to move outside of SPSS. You'll need to get AMOS out or switch to Stata or MPlus. If you want to do meta-analysis, you'll need to use something like CMA or Stata, and same with multi-level modeling. That really SPSS is the baseline. SPSS can do some multi-level modeling, but I wouldn't recommend it. Importantly, in R, you can do all of these things and more without having to switch to a new system. R will handle your basic data handling and your basic analyses. It will give you access to path and structural modeling through the Lavaan package and others. It will let you do meta-analysis using Metaphor and multi-level modeling using things like LME4. So importantly, everything that you will need to do all of your work will exist in R. And to that extent, beyond that, you can even write papers in R, and people do write their whole papers, every single stage of it, in R. I'm not saying that you should immediately go out and try to do that, but this is something else that you can think about. That R will give you options for doing things that you haven't even thought that you might want to do yet. So importantly, packages allow you to get new analyses without new software. It means there are no additional costs. There's less learning time. It's already in the environment you're in. You don't have to have SPSS and AMOS and CMA installed just in case you need to do a particular type of analysis that isn't in the baseline. And as I was saying earlier, new methods get adapted relatively quickly. So things will happen within months rather than years when new features come in. And as I was saying, all sorts of weird things happen in R. This presentation is written in R. Every single piece of text, every script, so on, is built in R. And that can have all sorts of advantages because it means that I can do analysis in the background of my presentation and have it generate figures or calculations or things like that. So that's really one of the great reasons why I'm a big fan of R, in case you hadn't realized. So importantly, R does take some acclimation. You've probably felt this already, and it's probably been a barrier to you learning R before now, but it isn't too bad, I promise. And the important thing, I think probably the most important thing to realize is that making mistakes is completely normal and part of the process. If I write something, if I'm doing something in art, if I don't make mistakes, it's a miracle. Part of working in this type of environment is learning to have a certain degree of distress tolerance. When things go wrong, take your time, go back, think about what might be causing your problem, and work through that problem. Troubleshooting is part of working in art. And to that end, I recommend that people have a rubber duck. This is a thing from programming subculture. There is a process called rubber duck debugging, where when something goes wrong with your code and you can't work out what's going on, you should take your rubber duck and explain your code line by line. Because in explaining your code to anyone, including your rubber duck, it will force you to think more slowly about exactly what you're trying to get R to do and what you're asking R to do at each step. And in so doing, it will help you identify those problems. So if you do not have a rubber duck or equivalent nearby, I'd recommend as a good work process buddy, getting something to talk through your code to. So important to remember, learning any new stats package is always like learning a new language. It's frustrating to start, but really in the long run, it's super rewarding. And R is no different. In fact, R is probably the most rewarding statistical language that I've taken the time to learn by far. When you start to feel like it's getting you down a bit, remember, it will pay off. It will be awesome and it will be worth it. So what I would recommend for those of you, hopefully you have your RStall set up and RStudio set up, I recommend you shut RStudio down now and then go to either through Finder or Windows Explorer or equivalent, go to your Foundations R file and open it there. And then work through the script at your own pace. Basically, it's going to provide a set of comments which will explain what you're doing at each step and give you tasks to do that will hopefully build through an increase in complexity so you can build up that mastery. Where you have difficulties, I'd recommend trying Rubber Duck, and failing that, I'm happy to answer questions via social media some of the time, so tweet at me and we'll see if we can't give you some help. What should you do after the workshop? Now, once you get through, you'll hopefully feel like you're a little bit more competent and confident. You won't feel like you should necessarily switch over your workflow to R, but I would encourage you to really strongly consider it. It's one of those things that if you do not use this on an ongoing basis, you will not get better at it. And really, once you get over that first step, and remember that again, part of this process is troubleshooting, you will get better and it will make you able to do things that you couldn't have done in your previous systems. So I would encourage you to find a project that you're doing that you were going to do in another system and instead do it in R. Practice your way through to success. Experiment, play, try new things, and I'm sure that you'll find your way through. Importantly, when you get stuck, Google it. Use the help functions, so question mark and the function name, and use your Rubber Duck debugging methods to get through. I promise that it's really hard and it is really challenging, but once you start to make headway, you will feel it's entirely worth it.